Online children, my screen is visible to all, right?
Yes, ma'am.
Okay. So in the first one, we are given that AD equals AE and also AB equals AC. Now, the first thing we have to prove is that these two lines are parallel. Okay, so how do we prove that DE is parallel to BC? DE is parallel to BC. So for this, we want the proportion AD by DB equals AE by EC. We want this proportion. Okay, so if you have this proportion, then by the converse of BPT, DE is parallel to BC. Okay, so now what do we have? AB equals AC. Then we have AD equals AE. AD equals AE. When you subtract these two results, what do you get? AB minus AD equals AC minus AE. So AB minus AD is BD. BD or DB equals, when you subtract this, you get EC. EC. Okay, so now you have this result AD equals DE. And now by subtracting, you've got this result DB equals EC. Now when you divide one by the other, see, when you have A equal to B and C equal to D, then A by C will be equal to B by D. When we have two equations, A equals B and C equals D, you can perform all the four mathematical operations. Like, what are the different things that are true? A plus C is equal to B plus D is true. You can add the two equations. You can also subtract them. A minus C is equal to B minus D. Also, A into C will be equal to B into D. And A by C equals B by D. When you have two equations, you can use any mathematical operation on the two equations. So here we divide, we subtract, we get a new result. Yeah, we subtract and we get this new result. Now this we already have in the question, and this we just found. When you divide these two, what do you get? AD by DB equals AE by EC. AD by DB equals AE by EC. So by the converse of BPT, DE is parallel to BC. Okay. Now we have to actually show that these points B, D, E and C are concyclic. All right. So I've numbered these angles 1, 2, and 3. All right. Now because AB equals AC, AB equals AC, AB equals AC, it's an isosceles triangle. That means angle 1 is equal to angle 2 because the triangle is isosceles. See, AB equals AC. It's an isosceles triangle. AB equals AC. Isosceles triangle. So angle 1 is equal to angle 2. That is one result. Angle 1 is equal to angle 2. Okay. Now, angle 1 plus angle 3 is 180 because they are co-interior angles. That's why we proved that the lines are parallel. Why did we prove DE is parallel to BC? Because we want to write angle 1 plus angle 3 is equal to 180. We want to get 180 from somewhere. Because how do you prove that 4 points are concyclic? Opposite angles are supplementary. So you want that 180 degrees from somewhere, you want 180 degrees. That's why we proved DE is parallel to BC. So now, how are we using that information? Angle 1 plus angle 3 is equal to 180. Why? Because co-interior angles are supplementary. See it, parallel lines, transversal. These two angles are co-interior angles. They're supplementary. So we want that 180 degrees because concyclic we have to prove no 180 we want. That's why we prove that these two lines are parallel. And now we're trying to get 180 somehow. So this angle plus this angle is equal to 180. So we have from parallel lines, we have angle 1 plus angle 3 is equal to 180. But angle 1 is equal to angle 2 because it's an isosceles triangle. So instead of angle 1, you can write 2. So 2 plus 3 is 180. So you see opposite angles, they're supplementary. That means this one is a cyclic quadrilateral. BCED is a cyclic quadrilateral, which means the points B, C, E, and D are concyclic. How do we say it's a cyclic quadrilateral? This one is a quadrilateral, right? This part is already a quadrilateral. See, this one is a quadrilateral. How do you prove it's a cyclic quadrilateral? If you can prove one pair of opposite angles are supplementary. So we proved now 2 plus 3 is 180. One pair of opposite angles supplementary. Therefore, it's a cyclic quadrilateral, and hence the points B, C, E, and D are concyclic. So what is the procedure? We subtract. We have two equations in the question. Okay, we have two equations in the question. We subtract and we get a new equation. Now you should select what of these three equations, which one will help you to get this proportion. Okay, so you should observe and write them correctly. So here we have AD equals AE, AD equals AE, and by subtracting we got this one. So write it carefully, like correctly. Below AD you must write DB. You should write it correctly. Below AE you should write EC. AE you should write EC. Then when you divide, so place the line segments carefully one below the other. Now when you divide, you get AD by DB equals AE by EC. By converse of BPT, the lines are parallel. So why did we prove lines are parallel? Because we want to get 180. And how do we get 180? Angle 1 plus angle 3 is equal to 180. Co-interior angles are supplementary. But angle 1 is equal to angle 2. So instead of 1 plus 3, 180, we are going to say 2 plus 3, 180. If 2 plus 3 is 180, it's cyclic. If it's cyclic, then the points are concyclic. All right? Very simple proof. So here instead of 1 plus 3, we do 2 plus 3. So this one is a cyclic quadrilateral. And so the points are concyclic. I think the same question, by mistake, I put 2. There's an alternate working. It must have been exactly the same question, no? Yeah. Yeah, it's the same question, children. Maybe I've done it in a different way. That's all. So you see that this part is the same. This part is the same, children. See, from here on, lines parallel. This part is the same, children. So here, I've just shown a different working. We'll understand this also. Okay, ready? This one is exactly the first one. We have to prove. Maybe the wordings, they're different in the question. I don't know. I didn't read it fully, but show that the points are concyclic. And we have the same information. AB equals AC, AD equals AE. We have the same information. Okay, so here what I've done, I've written, this one here. And what is given here, this one here. Okay. Now directly I've divided, I didn't subtract. I've divided one by the other. But when you divide, make sure what is the proportion you want. You want AD by, listen to this, very simple, but if you don't focus, it might become difficult for you. Now we need the proportion AD by DB equals AE by EC. Or we want DB by AD equals EC by AE. Both are fine. Anything is so fine. Correct? Or we want DB by AD equals EC by AE. Okay? Anything is fine. So now this is given to us, this is given to us. Okay? Now, which order to divide? Should I write this one first and then this one, or this one first and then this one? How to divide? Whichever line segment you want. Now, this is the required proportion. This one or this one is the required proportion. Now, in these, okay, let me just say both are the same. So let me say this, which is the required proportion. You want AD by DB equals AE by EC. This is the proportion you want. Now, look at these 4 line segments. Which are the line segments you want? AD, yeah, I want AD. AE, yes, I want AE. AB, no, I don't want AB. I don't want AC. What you don't want, keep them in the numerator. What you want, put them in the denominator. That is a rule. Because the numerator will change, the denominator will not change. In situations here, I'm not saying always. In situations here, what we'll always do is we'll either subtract or add 1, adding 1 to both the sides, or subtracting 1 from both the sides. We'll do something like that. In these situations where we do +1 or -1, the denominator will not change. The numerator will change. I'll come again. So you want AD and AE, right? So keep AD and A in the denominator because the denominator will not change. The numerator will change. So these will go away. This AB and AC will go away. You don't want them, no? Let them go away. So put them in the numerator. What you want AD and AE, right? Keep them in the denominator, AD and AE. They won't change. When you add or subtract one on both sides, they will not change. So that is the idea. So keeping that in mind, I carefully write. I write AB is equal to AC first. AB equal to AC first, and then AD equals AE. Then I divide one by the other. So I get AB by AD equals AC by AE. Now what I have in the denominator, AD and AE. I purposely write this one first and then this one. So I have AD and AE in the denominator. So they'll not change. Now, should you add one or subtract one? Now, this one is, it's an improper fraction, if you can see here. AB by AD. AB is the longer line segment. AB is the longer line segment. And AD is the shorter one. AB by AD. Okay, let's add one to both the sides. Okay, let's add one. Let me say like that. Let's add one to both the sides. What do you get? AB plus AD. What is AB plus AD? Tell me. You can't say. That's why you should not add one. That's why you should not add one. So if you want, if you have that question, why should you not add one? Okay, we'll add one. So then what will you get? AB by AD plus 1. So that will be what? AB plus AD by AB plus AD by AD, correct? When you add one, let's just change this to plus. Change this one to plus. So you'll get plus and plus here. What is AB plus AD? AB plus AD, no, I don't know. Then don't add one. Subtract one. Also because this is improper, children. See. Okay, let me not use that now. So that's what it is. So just subtract one. When you subtract one, what happens? AB minus AD by AD is equal to AC minus AE by AE. Now subtract AB minus AD. AB minus AD is BD. BD. And AC minus AE. AC minus AE is EC or CE. And see, the denominators did not change. The denominators did not change. Whatever you have in the denominator, you have the same thing here till here. See? Now, what is it you've got? BD by AD. BD by AD is equal to CE by AE. So just take reciprocals on both the sides. That's what is called invertendo. Invertendo is taking reciprocals on both the sides. So you get AD by BD is equal to AE by CE. So this is the proportion you wanted. And by this proportion, you can say that D is parallel to BC. I'll just repeat. We have these two equations in the question. Write the two equations. Write the one which you don't want first. That is, what are the line segments you want? You want AD, you want DB, you want AE, you want EC. You don't want AB and AC then. Then write them in the numerator. Then these line segments AD and AE, you want AD, you want AE. Write them below as a second one. So that will come to the denominator. Now divide one by the other. So you get AB by AD equals AC by AE. So what you want, they're in the denominator. What you don't want, they're in the numerator. Now subtract one on both sides. So you get this. Take reciprocals on both the sides and you get the required proportion. Now by the converse of BPT, the two lines are parallel. And when lines are parallel, co-interior angles are supplementary. So 1 plus 3 is 180. But 1 is equal to 2. So 1 plus 3 is 180. Is also 2 plus 3 is equal to 180. So if 2 plus 3 is equal to 180, this is a cyclic quadrilateral. And so the points are concyclic. You can also do it like this. Here, it's the information given is ulta here. You have to prove that the triangle is isosceles. See, here it was given that triangle is isosceles. AB is equal to AC. Here it's given triangle is isosceles. Okay, so here you have to prove that the triangle is isosceles. So that means you should prove either this angle is equal to this angle or you should prove AB is equal to AC. All right? Okay. So by BPT, because it's given, no, D is, whenever it's given, D equals BC, just write the proportion. It may be of some use. When you have this D equals BC, just write the proportion. AD by DB is equal to AE by EC. Just write that. See, when it's numerical, you can, actually make out like what to do. You can think like what to do. When it's numerical, when you read the question, so if it's a numerical situation, you can think, okay, let me do that, this. You can think and get the plan of the answer in your mind and then execute. Proofs, I don't think you can do that. Like mostly you have to just start working and then you have to see what you've written and then continue. You can't like plan the proof, let me do that, this. No, it's difficult to do that because it's all in letters, no? It's not numbers. So right, when you have D is parallel to BC, right, by the converse of BPT, AD by DB is equal to AE by EC. Write that. Okay, write that. What else is given, children? BD is equal to CE. Oh, BD is equal to CE. These were equal. Like, see here, if you have A by C is equal to B by C, the denominators are equal. So they'll get cancelled. So A is equal to B. A is equal to B. So the denominators are equal here. How do you know denominators are equal? Because it's given. How did we write this proportion? Because these two lines are parallel. Then we are given that BD is equal to CE. BD. This one is BD. This is CE. We are given that these two are equal. So they get cancelled on both the sides. So like say I've substituted here. Instead of EC, I've written BD. Instead of this one, I've written BD. Can we see that? So like it gets cancelled on both the sides. So you have AD equals AE. AD equals AE. AD equals AE. Now, I told you, when you have two equations, you can add, subtract, multiply, divide. So now see here, you have AD equals AE that we just got. And we also know BD equals CE. Add these two, AD plus BD equals AE plus C. Yeah. So what's AD plus BD? AB equals AC. AB equals AC means triangles isosceles. So think like this, you don't know what to do. So what should you do? With this information, you should write something. You must, so see, this one is given, no. So write that. What is the result? If this is given, what is the result? Please write that. Only when you write, you will know what to do next. Okay, this is one thing you can write. Then nothing else. You have this one in the question. So write that. And look at these two. This one by parallel line. This one is also given in the question. Now compare these two. Oh, DBEC, DBEC. Okay, they're equal. So instead of EC, you write BD. So they get cancelled. So now you get a new result. AD is equal to AE. Now add the two equations and you get AB equals AC. And so it's isosceles. Finish writing? Can you? Okay. Now see, all, similar information. Now here see, angle 1 is equal to angle 2, BD is equal to CE, and you should show that DE is parallel to BC. So to show that DE is parallel to BC, you just want the proportion. Okay, so see here, so angle 1 is equal to angle 2 means what? What can you write from angle 1 is equal to angle 2? What can you write? AB is equal to AC. Angle 1 is equal to angle 2 means AB is equal to AC. Okay. Then what is given? BD is equal to CE. Now, what do you think should be done with these two? Huh? Subtract, because AB minus BD will give you what? AB minus BD will give you AD equals AC minus C will give you what? AE. Now, Hasif, tell me, what should you do next? To prove that D is parallel to BC, what proportion you want, Hasif? You want AD by DB equals AE by EC, right? Yeah, now tell me. You have AD equals AE, no? Write that AD equals AE. Do you have DB equals EC? Yeah, it's given in the question. PD equals C is given in the question. Now divide. AD by DB equals AE by EC. So by converse of BPT, D is parallel to BC. When you subtract to get a new result, you should know what proportion you want. You want this proportion. So on subtracting, you get the numerator, AD equals AE. You want DBEC, that's given in the question itself. So write that correctly. You should write it correctly one below the other. That you should adjust and write. Then divide the two equations. You get the proportion. And by converse of BPT, the two lines are parallel. That's what is here. Online children, finish writing till the fourth one?
Yes, ma'am.
Okay. Is the fifth one similar? Yeah, so in the fifth one, you can see I've done it in two ways. Because in some schools, they subtract one. So see, this one is common to both. Then you can do it like subtracting one on both the sides, or you can also do it like this. Or finish writing this one? No. No, yeah, please write on this. You just write one answer so that, you're like, you just write A, B, B, D. Don't write all this, children. Don't write all this. This is one method. Hmm. Yeah. Take down only this. So interested children can learn up the other. I won't say interested, like if you want to, you can just see the other method also. I've written that here also, sorry. Okay, I've written the answer completely. Sorry, sir. I just noticed it's here completely, children. I've written, I thought, okay, this is one answer till here. From here, this is the other answer. So you take down only the solution. I'm sorry. This is one solution. This is the easier one. Done? All right. Okay. So we'll first take up the triangle in which we have these two lines parallel. Tell me the triangle in which these two lines are parallel. Name the triangle. In triangle B, BAC or BCA. Okay, in BCA. In triangle BCA, which is parallel. D is parallel to AC. So by BPT, what do you have? This is a triangle. Here, this is the triangle. This is the, don't see the other lines. Don't see this line. Don't see the other things. Just see this triangle. Don't see all this, okay? So these are the 2 points. I mean, like, just see the triangle where you have B, C, A, in which D, E is parallel to AC. Just see only that part. The other line segments you don't see. Ignore them. Now D is parallel to AC. So what's the proportion by BPT? BD by DA equals BE by EC. Okay, have this. Have this. Now, which is the other triangle where you have another set of parallel lines? Name the triangle where you have the other set of parallel lines. B, PA, the whole triangle. BPA, the whole triangle. B, PA, B, PA. Wherein, like this, you have D, C. Don't see the other points. Don't see the others. So this is the triangle BPA in which DC is parallel to, it's marked like this. Yeah. How is it marked? It's marked like this. It's marked like this. So again, in triangle BPA by, okay, in BPA, because DC is parallel to AP, by BPT we have BD by DA equals BC by CP. Now compare these two proportions. Here we have BD by DA. Here also we have BD by DA. So by comparing these two, we have a new result. BE by EC is equal to BC by CP. What is it we have to prove? B by EC is equal to BC by CP. Yeah, we proved. So you just have to write, use BPT in the two triangles, write the proportions, compare the two proportions, and you will get the result. Okay? Write down. Please, once the subjects come back. Okay. So such results, such results, see here. When will you get a result like this? Now, supposing here you have, say, for example, okay, so this is BD by DA, right? Now, supposing this is DA by CP, supposing DA by CP. Oh, not here, sorry. Yeah. So suppose this is BD by DA and say this is DA. This was say DA. This is the comparing thing. So this is EC. Supposing this was EC. What's the result you will get? Now tell me. BD by DA, BD by DA, BD by DA, BD by DA. So you get BE by EC is equal to EC by CP. So when you cross multiply, what will you get? EC square is equal to B into CP. So when do you get a result like this? So you would have written two proportions, compared the two proportions, and you would have got a new proportion. In the new proportion, when you cross multiply, you can get a result like this. All right. But here, when you cross multiply, you will not get anything like that because all the four line segments are different. B, BC, EC, CP. But here, we see that this denominator and this numerator, they're the same. So when you cross multiply, you get EC square is equal to B into CP. So how do you get a result like this? Proportion by BPT, another proportion by BPT, proportion by BPT, another proportion by BPT. Proportion is this one. Two ratios are equal. No, this is a proportion. This one is a proportion because two ratios are equal. It's a proportion. So this is a proportion. This one is a proportion. When you compare these two proportions, you get a new proportion. And that new proportion, when you cross multiply, you can get a result like this. All right. So DE is parallel to BC. And then FE is parallel to DC. So use steps similar to the previous one and get this answer. Prove this exactly like the earlier one. One more step, you just have to cross multiply to get this result AD square is equal to AB into AF. Do this by yourself correctly. Got it? Bhavashya, got it? No? Okay. Got it, Hassan? Right. Okay. You're getting it then. You've not completed. Okay. Couldn't get? Got it? Very good. Online children? Got it? No response. Okay. So first DE parallel to anything first, but because it's D parallel to BC first, I'm just taking that first. DE parallel to BC. So in triangle ABC, in this triangle, DE is parallel to BC. So the proportion is AD by DB equals AE by EC. Then FE is parallel to DC. So that is this triangle. A, D, C, F, E. Correct? FE is parallel to DC. FE, DC, AF. Correct? So what's the proportion we'll get here? AF by FD is equal to AE by EC. Correct? Now what is common? A by EC, A by EC. So you'll get AD by DB is equal to AF by FD. How do you get the result?
You should take reciprocal and add 1.
Correct. Correct, children? Do you all get this? Okay, when you compare the two results, you get this. Now you see when you cross multiply, actually you're not getting, there's no line segment common at all. So here, what is this? Let's just work on this. You have AD squared, that is AD into AD is equal to AB into AF. Correct? AD squared means AD into AD is equal to AB into AF. So what are the line segments you have here? You have AD, AF. AD, AF. You need, okay, and you have AD, you have AD and AB. You need to get AB. In this result, see, I'm just comparing this result and the proportion I have. I'm comparing this result and the proportion I have. Okay, so here I have AD 2 times. I have only AD once here. I need another AD. I need another AD and then AB, because we only have AD and AF, AD and AF. By comparing, this is the proportion we have. But this is the result we need to get. AD into AD is equal to AB into AF. Now let's compare the line segments in these two. AD 2 times we have. Here we have AD. Here AB and AF. We don't have AB, but we have AF. Now, is this in the final result DB? No, it's not there. Is FD in the final result? No, it's not there. So you don't want FD and DB, right? When you compare, you realize that you don't want DB and FD. You don't want them. DB and FD, I don't want. It's not there in the final result. What you don't want, keep it in the numerator. What you want, you put them in the denominator. Because denominator only will not change. Numerator will change. So this DB and FD you don't want. Then keep them in the numerator. So take reciprocals on both the sides. So you get DB by AD equals FD by AF. Now you want FD. You want FD that you want AD. That's in the result. You want AF, that also is the result. Now add 1 to both the sides. Add 1 to both the sides. So what do you get? DB plus AD by AD is equal to FD plus AF by AF. So what do you get? What do you get? What is DB plus AD? DB plus AD. DB plus AD. See the figure. AB by AD equals, what is FD plus FD plus AF. See the figure. FD plus AF. AD by AF. Now cross multiply this. AD square is equal to AB. So when you compare the two proportions, we got a new proportion, but when you try to cross multiply, you're not getting the result. So what do you do? Just stop. Don't cross multiply. Wait. That new proportion which you have and that answer which you get, you compare the line segments. You compare the line segments. Okay, so the two proportions we have are, one is AF by FD equals AE by EC, and the other one is AD by DB equals AE by EC. I drew the triangle separately. You should draw like that. If you're confused, please draw separately and see that. Okay. Now, when you compare these two, what do you get? You get AF by FD equals AD by DB. And you compare these two. AF by FD is equal to AD by DB. Now in the result, what are the line segments you have? AD, AB, AF. AF is there and AD is there. Is FD and DB there in that final result? No, it's not there. So that means you don't want that, no? If you don't want, put it in the numerator. So take reciprocals on both the sides. FD by AF is equal to DB by AD. Now add 1 to both the sides. You can put +1 here or here also, like this you can put anywhere. Add 1 to both the sides. So what do you get? FD plus AF by AF equals DB plus AD by AD. So what is FD? See the figure, what is FD plus AF? FD and AF is AD by AF equals DB and AD is AB by AD. Correct? Cross multiply. AD square is equal to AB into AF. Sometimes you will get it at this stage itself, like proportion, compare new proportion, cross multiply, you will get it. You can get it like that also. If you don't get, this is what you should do. Sometimes what? BPT, you will write a proportion, and BPT another proportion. Compare these two proportions, a new proportion. Cross multiply, you will get the result. If you don't get what you should do, that new proportion which you get, that after comparing, you get a proportion, right? That proportion and the result you should compare. You should identify which line segments you don't want. That you put them in the numerator. What you want in the denominator and add 1 to both the sides. You will get it. Yeah, take down the proof, children. Oh, this have, okay, 1 minute. This I've written proportion directly with all schools don't accept this. I'll work it quickly. Please write down, children. Okay. Yeah, go through this one. This also. Yeah, please go through this. Mhm. Yeah, go through this one. We can also do this using similarity. We'll do that. This is using the same question. We can do it using a similarity also. Write down the question. Don't waste time. Write down the question. As you write, just understand, children. We'll also discuss this. And the angles you need not mark. Sorry, huh? This is only for the similarity. Don't draw this figure again, children. This is not needed. This is not needed. This is only for similarity, not for PPT. Don't draw that. Okay. So I'm just showing you the different ways of doing it. That's all. You can do this one exactly like we did the earlier one. I'll work it like that also. Exactly like we did the earlier one, you can do this also. I'll just tell you what I've done here. This may be a little lengthy. Okay, now see it. First is you have to identify the triangles, right? Where the lines are parallel. So, which is one triangle where you have the parallel lines. What is parallel? XM is parallel to CA. XM is parallel to CA, right? XM CA. XM, this one is XM. This one is XM. And which is CA? Oh, XM is parallel to BA, sorry. BA. XM is parallel to BA, sorry. XM is parallel to BA. So which is a triangle? See, you should choose triangle so that when you choose two triangles, they must have a common side. That's very important. Now here we have two sets of parallel lines, right? We're going to take two triangles. The two triangles which you take, they must have a common side. Only then you can get a result like this. You must choose the two triangles in such a way that they have a common side. You cannot, okay, these two lines are parallel, so we can take the triangle ABC. No, but that will not work. You must take two triangles so that they have a common side. So see, in both these triangles I've taken, I want you to think, I've told you the idea. The idea is you cannot take any two triangles. The two triangles which you take, they must have a common side. That's the rule. They should have a common side. Now see, I have taken the triangles TXM and TCM, where TM is the common side. TM is the common side. TM, see, TM is the common side. So that will, the ratio which you get on that side will be the common ratio, TN by NM. Here, TN by NM, that will be the common ratio. You understand? So we have taken one triangle, TMX. The other one is TMC. TMX, where this is parallel to this. And TMC, where this is parallel to this. I told you this figure is for similarity. By mistake, I've put it here. Please identify two triangles with the given set of parallel lines, and the two triangles must have a common side. So when you take TMX, which are the parallel lines? BN is parallel to MX. Why BN is parallel to MX? Because it's given that BA is parallel to MX. See here, BA is parallel to MX. When two lines are parallel, any part of the first line and any part of the second line also are parallel. right? We have XM parallel to BA and we have XN parallel to CA. Okay. So in this triangle, we have taken in this triangle TMX, what have we used? XM parallel to BA. XM parallel to BA. See, this is BA, but the whole of BA is not there. That's okay, but we have a part of it. No, we have BN. We have BN. BN is a part of BA. BA, BN. BN is a part of BA. And BA is parallel to XM. So BN is also parallel to XM. We write the proportion. Then the other triangle is TMC, where TMC, where again TM we have. Here, which are the parallel lines? XN is parallel to AC. But you don't have AC in the triangle. It's okay. You have MC, which is a part of AC. XN, the second one. XN is parallel to CA. No, but we don't have CA in this triangle. That's okay. We have MC, which is a part of CA. That's enough. So we're using the second set of parallel lines, XN parallel to CM, using this triangle TMC. Now the triangles which we have taken, TMX and TMC, they have TM as a common side. That's what is important. Okay, that's one thing. That's about choosing the triangles. Then you'll ask me like, why you've added one here? Okay, so if you can't make out that we should add one, we can add one later also. I'll do it like that now. But here I'll tell you what I've done. I compared this one with this result. I compared this with this result. Okay. Now identify the line segment which is there. TB, BX. Compare this and tell me. TB is there. Then BX, TN, and then nothing is there. Only TB. Only TB. Only TB is in the final result. So I want TB in the denominator. See, this result and this one when I compare, no, only TB is there in the final result. So I want TB in the denominator. So I take reciprocals on both the sides. BX by TB is equal to NM by TN. And I add 1 to both the sides. And you know then what happens. Then I take the other triangle. I write the result by BPT. And I compare this result with this result. TX is the only thing I have, TX. The others I don't want, XC, TN, and then nothing I want. I want only TX. So I take reciprocals on both the sides. I put TX in the denominator. TX I put it in the denominator. So I take reciprocals on both sides because I know that the denominator will not change. Then I add 1 to both the sides and I get this result. Now when you compare these two results, TM, 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 TN. So you have this equal to this. And when you cross multiply, you get the required result. But if you think, how do you know you should add one? You can also do it like this. Is this fine? So what are the things you have understood from here? You cannot take any two triangles. You have to take two triangles that have a common side. So here TMX, TMC. They have a common side TM. And the other thing is, it's not that you should take, okay, the two sets of parallel lines are XM parallel to BA and XN parallel to CA. It's not that XM and BA fully should be there in the triangle you take. It can be a part of XM or a part of BA, or XM fully and a part of BA, or BA fully and a part of XM, anything. Parts of them or full or part of one and full other, anyways. But it's not that XM fully should be there and BM fully should be there in the triangle which you're going to take up. It's not like that. Am I clear there? Okay. So the two triangles must have a common side. And it's not that XM and BA completely must be in the triangle and XN and CA should completely be in the triangle. Okay. Then we write the results. So we identify the triangles and we write the results by BPT. We write the results by BPT. Then what in this procedure, what I've done is I've compared this one with the result here. And the only line segment that is common is TB. So I put TB in the denominator. I take reciprocals on both the sides, add 1 and I get this result 1. Here also when I compare this one with this result, Tx is the only line segment common, Tx. So again, take reciprocals on both the sides, add 1 and you get this new result. So we've called this 1, we've called this 2. When you compare 1 and 2, Tm by Tn, Tm by Tn. So we have this new result and on cross multiplying, we get what we have to prove. Now I want you to try this without adding 1 here. Like, so what I want you to do is don't do this. Okay, don't. So write this triangle, parallel lines, write this proportion. Then write this triangle, parallel lines and this proportion. Compare these two proportions, Tn, Nm, Tn, Nm. You get a new proportion. Then you compare that proportion with this one and see if you should take reciprocal. Then add 1 to both the sides and see if you're getting the result. Do it, all of you. And just strike out what I don't want you to work. I want you to, this proof all of you have written. Now do it like this. Write only this part. Don't write this. Write only this part. Don't write this. Write this one and this one. Compare and get the new result. Alternate method. Got it? Got the result? Very good. That's all it is. You can do it like that also. Which is easier? The second method. Less steps. Yeah, that's all. Less steps. Got it? Yeah. Very, very important is choosing the triangles. They must have a common side, otherwise you will not get the result. Okay. The alternate method is do it here. Yeah. So when you compare this with the result, we don't want bx and xc. Bx is not there, xc is not there. What you don't want, take to the numerator. So take reciprocals and add 1. Yeah, check your answer. I'll just come back to them. Easy, right, children? Okay. Again, I repeat, the important thing is, yeah, identifying the two triangles. The two triangles that you take up should have a common side. Like your TM is completely common to both the triangles. That is very important. And then those parallel lines, you should not, it's not that those two line segments mentioned should completely be in the triangle. Not like that. Okay, any part of the lines can be there or the full lines can be there. Any part is also okay. So triangle, parallel lines, use BPT, write the proportion. Again, another triangle, parallel lines, BPT proportion. Compare these two proportions, new proportion. Compare this new proportion with the result you want to prove. Compare this new proportion with the result you want to get. So the line segments which are common are TX and TB. BX, XC, you don't see that in the result here. BX and XC. No, BX, XC is not there. But the numerator TB and TX, yeah, TB is here, TX is here. What you want, you should keep it in the denominator. So we take reciprocals on both the sides. We take reciprocals on both the sides. So we have TB and TX in the denominator here. TB, TX in the denominator. So they will remain. Now add one to both the sides. Cross multiply will get it. இந்த ஐடியா யூஸ் பண்ற மாதிரி தான் வேற வேற ட்ரையாங்கிள்ஸ் கொடுப்பாங்க. ட்ரையாங்கிள் எப்படியோ இருக்கும். ஐடியா இவ்வளவுதான். This is only the idea. Okay. These I need to write the answers. So maybe whatever answers are there, we'll do it now. Yeah. This also you can do it by yourself. Try. Oh, what did I do? Wait. Here you will have to prove QR is parallel to AD. That is by converse of BPT. Yeah, no hurry. Think. Be very clear in your thought. Just don't write something. Got it? So name the triangle. PQ parallel to AB. Which triangle? Angle BAC. Correct? BAC. Correct. ABC. BAC 1. ABC. Correct. Then PR parallel to BD. Which triangle? PR, BD, BDC. Correct. Or BCD. So they have a common side, these two triangles. BC is a common side. You can say BC, ABC, BCD. BC is a common side. Only when they have common side, there will be a ratio which is common in both. See, when you write the proportions, how do you compare? Because there's one ratio in both the proportions. How will you get that ratio in both the proportions? That's only when the two triangles have one side in common. Yeah, continue. So what's the proportion? PQ parallel to AB. What's the proportion, Bhavishya? B?
PR by RC.
Oh, you're saying for this one, I think, BCD. ABC triangle.
AQ by QC equals B.
AQ by QC equals
BP by PC.
BP by PC. Correct. Next one.
PR by RC equals BP by RC.
Yeah. So you must, because BC is the common side, you must maintain the same ratio. If you write BP by PC, if you write BP by PC, it's DR by RC. You can see BC is the common side. So in one triangle, if you write BP by PC, in the other triangle also you write BP by PC. If you write CP by PP, write CP by PB in both. Okay. You can also write that common thing first. You can write the common thing first. What's that common thing? BP by PC. BP by PC. equals, you write BP and PC, you write AQ QC, AQ by QC. So write the same thing, BP by PC equals BP, yeah, DR by RC, DR by RC. Now from 1 and 2, from 1 to AQ, yeah, AQ by QC is equal to DR by RC. AQ, AQ and QC is equal to DR by RC, which is a triangle. AQ, QC, DR, RC is a triangle ACD. In triangle ACD. From 1 and 2, from 1 and 2, what do we get? This one, in triangle ACD. See, where is the triangle ACD? Here. AQ, AQQC, DR, DR, RC. Can you see this? AQQC, DR, RC. AQQC, DR, RC. This triangle. So if AQ by QC is equal to DR by RC, that means QR is parallel to AD. QR is parallel to AD. That's all. So how did we get, why are we getting BP by PC, BP by PC in both the triangles? Because BC is a common side. If the two triangles did not have any common side, you will get proportions, but no ratio will be common in both. Then you cannot compare the two. Therefore, QR is parallel to AD by converse of BPT. By, or we can write by converse of BPT. Converse of BPT. QR is parallel to AD. Okay. Next one. We'll do this. The side BC of triangle, I think we'll not have time to work this, so I'll just explain. I'll share the image, complete the answer at home. The side BC of triangle ABC is bisected at D. So D is the midpoint of BC. Okay, so BD is equal to DC. O is any point on AD. O is any point on AD. Okay. O no is any point on AD. All right. BO and CO produced BO and CO. When you produce them, they meet in E and F respectively. They meet in E and F respectively. Okay, all that is. And AD is produced to X. AD, where's AD? AD. It's produced to X. So that D is the midpoint of OX. D is the midpoint of OX. So now these midpoints are only information for us. So what are the midpoints we have? We have this D is the midpoint of BC. D midpoint of BC in the first line, bisected. Okay, then now it's mentioned that D is the midpoint of OX. D is the midpoint of OX. D midpoint of OX. These two things are important for us. These two things are important. See, all the rest of it is just explaining the diagram. You don't have any equalities or any relation you don't have there. You're just explaining the diagram that this one is produced and it meets something somewhere and all that. But what is it you can write from this information? So I think you can only write D is the midpoint of BC, D midpoint of BC, and D midpoint of OX. It's given here. See, D is the midpoint of OX. Okay, that's all. So the rest is what you see in the figure. Okay, you can see the figure. Information is D is the midpoint of BC, D is the midpoint of OX. This is only the information. Now with this, you will have to show that AO by AX, AO by AX is equal to AF by AB. We must prove that AO by AX is equal to AF by AB. Such proportions you can get only when lines are parallel. See, this is the proportion by BPT, right? So that means this F4 should be parallel to BX. F4 should be parallel to BX. Only then you'll get this proportion. Here, I'll tell you. This one, this first part, when can you get? See, look at this triangle. ABX triangle. Okay, in this triangle ABX, if FO is parallel to BX, don't see these lines again. Okay, if F4 is parallel to BX, then what will you get? AF by FB is equal to AO by OX. And then you can add 1 and all that and get this result. See, AO by AX, AO by AX, the full thing, is equal to AF by the full thing AB. So you'll have to prove that F4 is parallel to BX. Only then you can get that proportion. And then you'll have to also show that FE is parallel to BC. If you have to show that FE is parallel to BC, FE is parallel to BC, you need to get this proportion AF by FB is equal to AE by EC. Then by the converse of BPT, FE is parallel to BC. This much we can understand. Now, how do we execute this? Now, when you have to prove, see, this is the information we have, only midpoints we have. But we have to prove parallel lines. This, I told you, to get this proportion, you need parallel lines. But we don't have anything, we just have this information. So now go back to standard 9 and use this information in this quadrilateral. In this quadrilateral. Because you see, we have only this information. So how to make use of this information? D is the midpoint of BX, D is the midpoint of OX. Okay, D is the common midpoint for two line segments. So take up the quadrilateral BXCO, this one. Because here you have BC, no? And you also have OX. Why did I take up this quadrilateral? Because I have BC and OX as diagonals there. I have BC and OX as diagonals. See, BC and OX. These two are diagonals of BXCO. So then how is this information helpful? D is the midpoint of the diagonal OX. D is also the midpoint of the diagonal BC. And we know that in a quadrilateral, when the diagonals bisect each other, it's a parallelogram. And if it's a parallelogram, we have parallel lines. No, opposite sides are parallel. So somehow we need to get parallel lines. Okay, so how do you make use of this information and get parallel lines and show that the lines are and show that some lines are parallel? So we identify BC and OX. We understand that they are diagonals of BC and OX. So we see that they're the diagonals of the quadrilateral BXCO. and D is the midpoint of both the diagonals. That means the diagonals bisect each other. And in a quadrilateral, when the diagonals bisect each other, it's a parallel. If it's a parallelogram, then this is parallel to the opposite side of the parallel, and this one is parallel. Just one A, we got parallel lines. Now, if OC is parallel to BX, now the CO is produced, no? So CF is also parallel to BX. CF, opposite sides parallel. We got CO is parallel to BX. But CO is produced. So CF is also parallel to BX. What is the other part there? OF. OF is also parallel to BX. Everything on this one. See, CO is parallel to BX because opposite sides are parallel. Now CO is produced, no, like this. So that means this OF is also parallel to BX. That's what we wanted. We wanted OF parallel to BX. That is in this triangle now. That is in this triangle. So in this triangle, these two lines are parallel. By BPT, you can write the proportion, add one, and get the result. The first result. Now, in the same way, XC is parallel to BO. Opposite sides parallel. Now, BO produces BE, right? Now, you don't take BE. Take only that little thing. Take this little portion OE. Take only this little portion OE. So, OE is also parallel to XC. Here also, we took only that little portion. We didn't take the whole thing. See, here also, BX parallel to OC. Okay, so the OC is produced. So we have OF also there. We have OF. So we took OF parallel to BX, and that is in this triangle ABX. Similarly, CX is parallel to BO. Don't take that BO. Take OE because it's BO produced, right? So take OE. So OE is parallel to XC. And that is in which triangle? In triangle AXC. Now, these two triangles, don't you think they have AX as a common side? So when you write the proportions using BPT, because parallel line, you have a set of parallel lines in ABX, you have a set of parallel lines in ACX. So when you write proportions, when you compare that, you will get, AF by FB is equal to AE by EC. When you come, because they have a common side, no? So you will get, you can compare and you will get this proportion. AF by FB is equal to AE by EC. So by the converse of BPT, FE is parallel to BC. All right. So what's important here is to prove that BXCO is a parallelogram because that's what we can do with the given information D midpoint of BC and D midpoint of AX. All right. I'll share this image on WhatsApp, children. Please complete this by the classroom. All right, children. So that's it for today's session. Online children, use the emoji, raise your hand.